All right, so we're going to continue the notes from yesterday. We did not finish all the items here. So we solved for one thing, but we did not solve for them all. So as we start off class, we're going to start off class. And so let's see. You guys ready? Are you ready? All right, let's see. So class.
Yes.
Thank you. Appreciate it. Mario. Can I get like a what's up? No, I can't. At least try. Okay. All right. So what's the first thing that we actually figured out? When we did this, we actually did where we ended up, the final location for my x value, right? And we did that twice. So I'm going to go through and I'm going to start listing the items that we know. On this problem, we had more than one velocity. So you could actually see different notations or ways to actually write it out. So I'm going to write it out. I'm going to say that my initial velocity, or my velocity 1, what was my first velocity? Louder. Okay, 3. Now, always units. Always units. Say it louder. Okay, so now listen. This is for everyone, not just you. Okay, let's pretend like I was in the military and I blew some stuff up and I am hard of hearing. So when students do not speak up or don't like enunciate and like project their voice, it just mumbles. Okay, so please don't do that. So it is what? Meters per second. So I'm going to write that out. Okay, there's my first velocity. My second velocity. No, wait, before I do that, let's take a look. My first time. My first time. What is it? 6 seconds. Second velocity. -7 meters per second. Very good. With the units. The second time. 3 seconds. So if you didn't have all this information down, maybe you should be writing it down because it is super important. We had my initial x was, where did I start at? -9. Very good. -9. After we did the problem yesterday, we had an x final. What was my final x position? Huh? Final. After we're done with all of it. -12. So if I did not have that, I make sure I have those. Now we're going to go through and actually look at all the things he was asking for. So we found the final position, which is my xf. My x of the final position was at -12. Velocity. Do I have it labeled up here? Yeah, because we have more than one velocity. Velocity, my first one is 3 meters per second. Good. My second velocity is going to be -7 meters per second. That's good. Speed. Now flip it over. Flip over your notes to the vocabulary. Read it carefully, especially that asterisk. That's a little star thingy. What do we know about it? Speed is what? absolute value of velocity. So if you guys eventually get to calculus and you're going to be doing it, a lot of the things that you're going to be doing, this is actually going to be key to a lot of it. Key. Absolute value of velocity. What does absolute value really give me? What does that do? Absolute value does what? Positive numbers, no matter what, right? Now, go up in your notes, you're looking at your vocabulary. Look at distance. What's the asterisk for distance? Can't be negative, right? Can't be negative. So, as we go through, and I actually ask you about this, I'm going to say that distance is always positive, right? It's always positive. Distance is always, class, distance is always, Now say it with feelings, because I'm going to keep asking you over and over again, because distance is always, it's always going to be positive. Speed is always going to be, so it's always positive, right? Because we're taking the absolute value, and the absolute value is going to give me a positive number. Now, in mathematical theory, there's people that say that 0 is neither positive nor negative. It's positive. It is. It's positive. Now, odd numbers. What are odd numbers? Someone give me an example of odd numbers. I am so glad I don't have crickets in here, because I would only be here in chirps. Odd numbers. 1, 3, 5, 7, 9. Oh, you guys are going to love me, because when it comes time to do stuff out of the book, I'm going to assign odd numbers. I'm going to assign even numbers. And if you don't know what that is, you're going to have to do them all. So, now, I'm going to go backwards with those odd numbers. 9, 7, 5, 3, 1. What's the next one? -1. Is there a pattern to what we're doing? There is a pattern. What's the pattern? Just skipping one, right? So from -1 it goes to -3, then very good. Even numbers. Even numbers. Hey, 2, 4, 6, 8, right? But now go backwards. 8, 6, 4, 2, 0. Because look, 0 is an even number. It fits the pattern. And then -2, -4, -6. So, and so on, all the way through there. So as we're going, it doesn't really matter what direction we're going. Direction comes from my velocity. Positive moves to the right, negative moves to the left. As long as we like to move it. My distance is always what? Thank you. It's almost like I should have you say it 7 more times. Distance is always. Distance is always. Say it with feelings. Distance is always. Distance is always. Distance is always. It's almost like I'm trying to ingrain it in your head by saying it over and over again. It's almost important, because this is actually the basis of what we're going to be doing the whole year. So, distance is always going to be positive. Speed is also always going to be positive. Okay. So, we said speed is the absolute value of velocity. All right, let's look. For velocity 1, what is my speed? 3 meters per second. Okay. On velocity 2, what is my speed? 7 meters per second. Because it is always, thank you, it's always positive. Displacement. Now, displacement. Yesterday I had an analogy. I was talking in class. Okay, I would start here and walk a half a mile to Deuce Rose, and then walk backwards back to here. Go look at the definition for displacement, please. So, my definition of displacement. Perfect. Wrote that down, right? It's where's this? You know what I said? That makes me happy. Now, using that information and my analogy of walking to and from Deuce Rose, what is my displacement? Nope. I walked half a mile to Deuce Rose, and I walked half a mile back. Oh, the bear? Oh, talking about Deuce Rose right now. Okay, it's early in the morning. Everyone should be thinking about coffee. So what is my displacement? Perfect, 0. It's 0 because my starting location is the same as my ending location. My displacement is 0. Now let's go look at the bear. The bear started at -9. The bear ended at -12. What is that displacement? Just 3. Because it says distance from your starting location. So my displacement is 3. Total distance traveled. The bear took 2 trips. So my first trip starts at -9 and ends at +9. What is that distance? It's 18. How did we get 18? So my distance total is going to be my velocity 1 times time 1. Why am I putting absolute value bars around that? Stay positive. Distance is always positive, so I'm putting absolute value bars around it because distance is always, thank you, distance is always positive. Okay, so my total distance, I'm going to add the next one. Absolute value, it's my velocity 2 time 2. So, filling it out, my first one we said was 18, right? So we have 18 for the first one. 18 plus velocity 2 times time 2. So that is going to be -7 times 3. -21. Absolute value is going to be +21, right? So my distance total comes out to be 39. What is my units? Meters. So we did most of this math yesterday, and we're just filling in the last things that it was asking for. All right. Next part of the notes. There we go. We have acceleration. And I got a problem with this one right here because C does not match anything. Alrighty, let's go through here. Acceleration happens when an object speeds up or slows down. Acceleration is the rate of change of velocity. So it is the final velocity minus the initial velocity divided by the change in time. Or in the equations, A is equal to delta V, which is the change in velocity, or over delta T. Or I have for my V final, my final position is equal to my V initial, my initial velocity is going to be, did I say final position? No, yeah. So V final, so it's my final velocity plus my acceleration times change in time. Now, if a velocity is a velocity and acceleration are same direction, an object is speeding up. Now, this is where a lot of people are going to mess up because they're not going to pay attention and write this down. This right here means, are they both positive or are they both negative? They have to be the same sign. Both positive and both negative means that they are speeding up. If velocity and acceleration are opposite directions, different signs, object is slowing down. So in this right here, you're going to hear this a lot for the entire year. Object is moving to the left. That is a positive. And it has a positive acceleration. That means it's moving to the left. It's increasing at an increasing speed. So, we do this again. So watch my hand motion. Because positive means it's going to the right. So it's going to be increasing. So it's going that way at a increasing speed. So it's going up, right? Because it's positive. This one right here. So the next one, it is negative. So negative goes to the left. So if it's going to the left, that's negative at a negative speed. So it's increasing at an increasing speed. So if the signs are going, so it's actually going that way at an increasing rate. I know it's weird, but the signs are the same. Now, we do it the other way. We do it the other way. So if the signs are different, if it's increasing, that means it's moving positive at a decreasing rate that's going down. So that means that it is moving to the right, but it is slowing down. Okay? Because this is going this way, this is negative, it's going to be the opposite way, right? So that would mean it's going to be moving to the left. And if that means it's going to be positive, right? So that means that it is going against the way that it's going. So that would be decreasing at a decreasing rate because the signs are different. Going to the left, the sign is negative. But then if my acceleration is going up, that means the signs are different. So that means that that is going to be decreasing at a decreasing rate. So it's moving to the left, but slowing down. Okay? If the signs are the same, it would be moving to the left at an increasing rate. So going the same way as the direction. I know. Sounds kind of weird, right? Now, along with that, we have, acceleration. Now, acceleration, does that look like a mathematical formula we use or you use all the time, been using for a while, especially in geometry? It's something basic that you've been using probably since 5th grade. What does that formula look like? You've been using a lot. Right here for this equation, A is equal to delta V over delta T. You guys have been using it since like maybe 5th grade, 6th grade. The slope formula. Delta Y over delta X, change in your change in your y over change in x. That's all this is. It is a slope formula, but acceleration is the slope of velocity. Velocity is the slope of position. And when we get to graphs, hopefully it'll make a little bit more sense as we do that. All right. Okay. Now, I apologize. These notes that were given to me, this example does not match because it starts talking about a cat. A Chevy Bolt is initially traveling at 20 meters per second and decelerates for 6 seconds before stopping. Calculate the cat's acceleration. It's kind of weird, right? Yeah. Anyway, so disregard the fact that it's talking about a Chevy Bolt and a cat at the same time. Let's write down what we know. Every time we do one of these problems, that's how we start it. What do we know? Initial velocity, right? Okay, initial velocity. What is my initial velocity? 20 meters per second. There is a second velocity there. What is my second velocity? No, that's time. Loud and clear. How'd you get 0? Stop it. If I stop, what is my velocity? 0. I'm not moving anymore, right? So my second velocity is going to be 0. So I have to read through the problem very carefully, especially to find things like that. What's the next thing I have?
6 seconds.
6 seconds, which is my time, right? All right, so now let's go ahead. What do we have here? I'm going to write it out. What am I writing out? A equals what? Say it again.
0.
Very good, because it's my second one minus my first one over. Say it. 6. Yeah. Doesn't say how long we're stopping for, so it's just going from there to stop. And that's the change in time that we have here. So in between there and there, it's only 6 seconds out. All right, now we got to do a little math here. We got to do a little bit of mental math. What do we get? Markle. Markel? Damn it. I keep trying. I just found out earlier today I've been calling a guy for like all week. I've been calling him Kevin, but his name is Luis. I don't know why, but yeah. So he's like, yeah, my name's actually sorry. Stop chatting at each other. Jake Quillen. You give me an answer here. Tell me what you get. Answer this. Hey, you don't look over there. It's right here. Do math. Math, not meth. You don't know math? It's just one guy I knew back in high school. Okay. He had the good stuff. You ready? Hey, look. What are you doing? What do you get? Which is it? Yes. 5/6. Go on. Come on, that wasn't a challenge. Wow, this is going to be a super long year. I'm going to be waiting on Jake Quillen all the time. Come on, Jake Quillen. How many times does 6 go into 20? 3. 6 times 3 is? 18, right? So it's 18. So I'm taking away 18 and I'm left with 2 over what I divide by? There you go. We have it as a fraction. Not so bad, right? Now we got to reduce that fraction. Yes, Jake Quillen, you're almost done. 2 over 6. Can I reduce that? Yes. To what? On the bottom right? Right? Yes. 3. And what's on top? Yep. So 3 and 1/3. Okay. We're getting there. We're getting there. What is 1/3 as a decimal? 0.3. 0.3 repeat. Because it's 0.3333, right? Okay, so my acceleration is going to be 3.3, repeating like that. Now the next thing is I'm gonna get you. Almost done, Jake Wallen. Almost done. What are my units? What are the units?
Meters per second.
Okay, close. Meters per second squared. Because this is actually velocity is meters per second. So that's a slope there. But I'm taking the slope of a slope. I'm taking the rate of change of the rate of change of velocity. So it is going to be meters per second squared. So acceleration is always going to be like that. It's always per second. Jake Quillen, thank you for playing along. You have earned it. Yeah. Uh-huh. Okay. So 3.3 meters per second. Questions, concerns, complaints, conspiracy theories. No? We're just sitting here waiting quietly for the teacher to leave us alone. Kinda. Working on it. All right. So I'm going to leave off right here before we pick up the next one. And trust me, the next one is actually like even worse. It's not just car and cat. There's like 3 different items in the next one. So we're going to pick up that one here not tomorrow. It's Monday. We're picking it up Monday. And what is due today? Notebook cover. What else is due? Online. AP Classroom, right? AP classroom, you had to go through, register, and watch one video. That's it. And I'll go back through and I see if you guys watched it or not. Anything else? Plan for success too, right? All right. So make sure you guys all like, share, and subscribe. Hit that notification button. Support my channel. Buy stuff from my merch store.